Talking about AI.
Hi everyone. Thanks very much for coming. Thank you. You haven't heard me talk yet. So thanks for coming along. So the reasoning really behind this, and especially the title for the presentation, we've heard a lot about AI this year. It's become a bit of a hot topic, a bit of a buzzword, and it promises to do everything from save humanity from sort of climate change, destroy humanity. It will be the next technology that's in everything. And while some of those promises may become true, I would argue that it's not true for all of them. It also puts us in a very difficult position as security people because we're essentially trying to learn how to manage a brand new technology. But this is more of a call for everyone to relax a little bit. We don't need to worry about it as much as we are. And in fact, a lot of the things that we're already doing, we can continue to do even with AI. So a little bit about me. Obviously, I've been introduced. Hi, I'm Sarah. That the name isn't a typo. I'm not Sarah Connor, so cannot provide that level of knowledge on AI. I'm currently working as a lead cybersecurity specialist. So I work primarily with developers on secure design principles, giving sort of best practice advice, that sort of thing. I also have the Secure Software Lifecycle Professional certification. So really anything to do with software, information security, that's my wheelhouse, that's my interest. At the bottom, I am very introverted, but I have ADHD, so the talk might run over, hopefully not. But come talk to me, I'm very friendly. Please approach me because I'm probably not going to approach anybody else, but I'm more than happy to have a chat about any of the stuff we talk about. Okay, so rough agenda for today, if it stays on track. First of all, I'm going to spend a bit of time defining what I mean by AI. And the reason I've spent some time sort of specifically calling it out is there's lots of different definitions for how you might describe something like AI. There's a lot of crossover between machine learning technologies. This is intended to be sort of a principles-based talk. I'm not going to get into the technologies, and I also don't have the time to get into the philosophy of when a machine is actually human or whether AI means true sentience. So I'll give you some framework to understand what I mean when I'm saying AI in projects currently. We'll then go back to basics. So we'll talk a little bit about secure software principles, things that we currently use today in order to sort of guide how we secure software. I'll then talk a little bit about how we can apply them to AI. So when we're actually looking at using something like AI in projects in businesses, what we can do with what we already have. And then I'll talk a little bit about unique AI risks, because there are a few that we need to be conscious of, but they're not as big or complex as they might first seem. So, onto the definition. I've tried to break it down into three broad areas. As I said, this isn't from a technical standpoint. So I'm broadly looking at the logic that the application will use, whether it needs training or not, and what the outcomes of that particular application will be. And I've handily broken them down into three here. So we've got traditional application. So this would be, if you're programming an application, it's going to be very linear. You go through lines of code one by one. It's going to be static. Unless you reprogram it or change it in a significant way, it is always going to follow those same commands one by one, unless you have timing errors or things like that. It doesn't require any training. It's built to do the thing that it's built to do. And the outcome is defined. You can't really program something with traditional programming languages without knowing what you're after, because you won't be able to tell the computer how to do it, essentially. With machine learning, however, what you've got here is evolving logic. So these are your kind of algorithms that are being refined to do something that essentially we don't necessarily know how it's going to do it, but the outcome itself should be defined. We should have a really clear sense of what that algorithm is intending to do. And that's how we tell it, essentially, whether it has completed it successfully or whether it hasn't. And AI moves more towards the human spectrum, where you've got that ongoing need for training. It's got evolving logic, hopefully the same as a human, but it's unpredictable. So for tasks where we don't necessarily know what we want, or we want to provide some information, but we don't really know what the output should be, AI is quite good for those tasks because it does have now the ability to be essentially not necessarily creating new things, but presenting them in a new way or combining them in a novel way. So back to basics. I think we've all seen these information security, very basic principles. You're keeping things nice and confidential, keeping things correct, and keeping things available. But to break those down, when we have a traditional application, so when you are defining sort of a component for an application, what you're really checking is you have assurance that it's working correctly and you have some way of checking up on it, reporting, monitoring, controls. I'll break that down in a little bit when we talk about how to apply it to AI, but in general, those are the sort of controls you're after when you're making a traditional app. You also have your human controls. So in an organization, obviously, hopefully you have users that are going to be using it, and they are going to need some limits on their behavior. So very much like you can't define essentially what a human's going to do with the system. If they have access to it, they will probably do it. If there's a big red button saying delete all my data, they might well press it. So access control is limiting what they can do and when they can do it. And then you also have a really interesting principle of psychological acceptability, which I'll get into, but essentially humans are really bad at doing things if they don't think there's any sense in doing them. So I'll talk a little bit about traditional application controls. So first of all, you have redundancy principles. So if you're defining a traditional application for business, you want to make sure that that application is resilient against things. And one way of doing that is redundancy. So if you are defining an application where it's got a particular function it needs to complete, if that function is unavailable, what happens? How do we prevent the system from breaking if that thing isn't available? So for AI, what we're really talking about is resilience. You need to make sure that if you are incorporating AI into your projects, first of all, it's resilient against either essentially chaos testing is a great way of doing this, but if there's unpredictable input or output, or essentially the system is behaving in an unpredictable way, what happens? What does it do? Does the system continue to function as expected? Load testing is very similar to that. So if you want to just hammer it with data, see if it breaks, see if it does things that it shouldn't do. And then maintainability. If you're going to be keeping this as a component in your application for a very long time, can you actually maintain it? Is it going to continue to function the way you expect it to over a length of time? You also have equivalence. So this is another component of redundancy, and this is going to be quite important for sort of large organizations or lots of traffic. If you have an AI and it's processing information, any change in the way that it's been trained or the logic it uses to form its decision-making could influence the output. And if you have something that's, say, a spare version of it, so you've got some redundancy in place, any changes to it may drastically change the outcome. You don't want a situation where component A is, say, swamped with information, so component B takes over. It has very different learning, and suddenly you have very unexpected outcomes from that process. You can also look at things like containerization. So any way that you can get that artificial intelligence to essentially be replicable, easy to use, easy to deploy, will make your lives a lot easier. So fail-safe, pretty basic principle for information security. If something goes wrong, you don't want it to be less secure than when you started. So an example of this is if you have a two-factor authentication system, and that two-factor authentication system isn't responding or is taking too long to respond, you don't want your login system to say, oh, actually, single factor is fine. It should prevent the user from accessing it so you don't have a less safe outcome. The problem when you're incorporating AI into these processes, however, is it's really unpredictable outcome, as we've spoken about. So what you need to do is try and identify some failure states, but they're going to have to be rather extreme. So if you're expecting text output from a particular algorithm, what you would want to do is set an upper limit to it. If you're receiving a report from it, you're probably not expecting up to like 1 million words, hopefully. That might be a lot of processing. So at the extreme end, you can put some boundaries in place where at least the output is not completely ridiculous or will cause your system to fail. There's also recoverability. So if something goes wrong, how do you get it back to the way it was? And for AI, you really need to be thinking about how you're going to replicate the output from it. If you're developing an AI to do a task and you cannot do it manually, that is going to be a massive risk to a business, because if it doesn't work, how is the business going to continue to do that function, especially if it's a critical function? we need to make sure that we can continue to follow the logic even when it doesn't operate. Even if it does continue to operate, that AI, you're basically beholden to any updates it needs, any kind of maintenance, and if it becomes very expensive to run, if you can't do it manually, you have to keep doing it. And then finally, data validation. So where you have data that is either going into it or out of it, you want to make sure it's as expected. And this is particularly important for AI projects because you're not necessarily aware of how it's going to send you back that data. What if one day it decides to send you back numbers rather than words and letters? So what you can do is have validation, and I'd argue in line with human processes. If you're expecting input from random users, use those same controls that you would with an AI. It's unpredictable, could be free text. Make sure it's in the format you expect and make sure that you're rejecting anything you don't expect. Onto the human controls, because they also apply to AI. First of all, you've got identity. So where we have human actors on a system, you want to make sure you know who's done what. And the reason for that is obvious. If something goes wrong, you want to be able to find the person that did it and ask them what went wrong. For AI, particularly if you have multiple versions of AI running, or if you have multiple components that use AI, you want to have some way of identifying the particular instance that was running at that time. And you need to have very strict version control. If you don't have strict version control, and as the logic evolves, it's making different decisions, how are you going to trace back and find out where that error occurred? For authentication, essentially, it's going to almost be running as if it's its own actor on your platform. So really, you need to have some way of validating it. Obviously, you can't really give it passwords because, as we know, AI will tell you things that maybe it shouldn't, if you have a chatbot, for instance. So instead of things that it knows, we should be looking at other authentication methods. Integrity checks. Can we prove that that process is running as expected? The input's not coming from, say, an external source. Are there certificates that we can use to validate the exchange of data? That sort of stuff. Finally, the big one, authorization. So we know what it is that is acting on our system or who it is, and they've proven it. But how do we check what they can do? So particularly for AI, we should be checking every single action that it takes, and granular access controls will be particularly important. The reason for this is if you have AI in a project and it's doing things within your system or making changes to your system and something goes wrong, the ability to withdraw access for doing a particular function would be quite valuable because it prevents maybe other changes on the system or other unintended impacts. You can just withdraw access to the troublesome part while you're trying to issue a fix. Otherwise, you have to essentially stop it from functioning altogether while you work out what's gone wrong. Separation of duties. These may all be very familiar to you. So separation of duties, making sure that one individual actor can't do everything. And again, this is really important for AI because, first of all, AI can have very unanticipated functionality, especially if you're asking it to do multiple things. It can get very good at doing one thing currently, but if you're asking it to do multiple things, sometimes it can do things in unintended ways. And that's where you have a risk of emergent functions. So it doing things that weren't intended by the original sort of use case for it. So really, we could look at separating out instances of AI. If you need to use it for several functions, have a different instance for each of those functions and make sure that they are segregated. They don't share permissions. They don't share the same access. And then finally, psychological. Now, I know I said I wasn't going to get into like the philosophical area of debate. But there is an instance in the future where AI does start to become more sentient or at least displays a bit more sort of autonomy than it does now. There's a massive topic discussion about AI safety. It's its own discipline. I cannot go over it in 30 minutes. But you can look at AI safety for looking at how to correctly motivate artificial intelligence, particularly when it becomes more autonomous, to make sure it's achieving the right outcomes. That's not one we have to worry about yet, but maybe in the future. So I did say I'd talk a little bit about AI-specific risks because they are an important problem, and I don't want people to come away thinking, oh, AI is nothing new, because there are things that we need to consider as professionals in the industry when we're dealing with it. But as you'll see, they're not as big as you may otherwise think. So the first one is data quality and confidentiality. So as I mentioned, AI, if it has access to information, will use it. When it's making decisions, and this is primarily your algorithms that are looking at a statistical outcome, so it's just computing what statistically is most likely for the outcome for what it needs, it will use anything at its disposal. There have been trials where they've been looking at, for instance, recognizing tumours in X-rays, and the AI was using file name data or font data within those X-rays to identify essentially the hospital that was running it, and hospitals with more patients are more likely to have positive X-rays, and essentially it was just very good at identifying where it came from rather than whether there was a tumour or not in the image. So, as I said with that one, data quality and confidentiality, obfuscate it if you don't need it, hide it if you can. For testing and training, so this is an important point, and there are now tools available to analyse the training data and the test data that you're using for these models, because sometimes these data sets can be massive. If you check your contents of the data sets, you need to make sure that when you're training your model, it's not also in your test data. Very often these large data sets can contain information that is sort of shared between multiple data sets. If it's already seen it and you've trained it, it already knows what the outcome should be. So it's not really presenting anything new. The problem with that is if you have a success rate with your test data about 80%, but 50% of it's things it's already seen and been trained on, it's not a validation of how it's going to work in the real world. And very often companies will find that once it's out in the real world, its success rate is an awful lot lower than it should be. And then finally, this is probably one of the biggest ones, is unrealistic expectations in business. So I'm sure over the last sort of 6-7 months, we've all seen stories where it's like they've tried to use AI for things. Was it really the best use of AI? Or were they just trying to do an AI project? There's a risk that businesses will run away and just find a use case because they want to be seen to be doing AI or having an AI project. So the question you really need to ask in those situations is, okay, so we've got an idea for how we might use AI. Are there better technologies available? Is there another way that we could essentially program this or manage this? Very much in the same way that we had a run of blockchain technologies over the last sort of decade. It's an excuse to kind of use the technology, and it's very exciting, but it's not necessarily the best use case for it. So just to go over, you don't need to reinvent the security wheel. That's the biggest takeaway I hope you take from this chat. We already have some very, very good principles for secure software engineering in place. And using them, just maybe looking at them through a slightly modified security lens, is perfectly fine. And in fact, it's probably going to make your lives a lot easier when the business come to you and ask you to start using these technologies, or maybe they already have. There are some challenges with how we are going to be incorporating these models into applications in the future, but they're not insurmountable. They're not going to be incredibly difficult as long as we've got the time and resource to look at those challenges and we're not getting bogged down with reinventing access controls or separation of duties principles. And it can be revolutionary. There's a lot of very, very interesting applications for artificial intelligence. Particularly, I've seen some, I think there's a talk today about how we might use it for sort of threat hunting. There's going to be some really, really interesting use cases that we can start to develop, and it's going to be able to do things much quicker than we can. But please remember, it's given the right use cases. And it may be that when you're talking to the businesses that you work for, sometimes maybe the hardest conversation about AI will be trying to convince them not to use it. So I think I've actually run ahead, which is great. That doesn't normally happen. But that means we've got plenty of time for Q&A. But if you don't want to ask me anything right now, you can contact me on Discord or find me today. As I said, I'm very friendly. I'm just, a bit of an introvert. So please come talk to me. Any questions from anyone? I'm not sure if the stunned silence is a good thing or a bad thing.